Kusuzangpo, welcome to Bhutan e-learning project. I am Nobazam and this is a mathematics lesson on fraction computation for Key Stage 2, classes 4 to 6. By the end of this lesson, each of you must be able to identify 3 types of fractions, write mixed number as an improper fraction and then an improper fraction as a mixed number correctly. You must be able to find equivalent fractions, and finally, you must be able to add and subtract simple fractions correctly. Now let's begin the lesson. To begin it, let me tell you a quick story. This is Karma. He has 1 apple, which he wants to share with his 4 friends. How many apples would each of his friends get? Will they get the whole apple? No, right? Now let's see what Karma does. He takes that apple and splits it in 4 parts. He gives a part to each of his friends. What part of the apple does each of his friends get? Each of them gets a quarter, right? How do we write a quarter? We write it as 1/4. Now 1/4 is the fraction here. A fraction is a part of a whole, not the whole. That is why a fraction is smaller than 1. Now let's learn some more about fractions. Look at this shape here. It's a rectangle, right? This is a whole shape. How many parts have this shape been split into? Let's count. 1, 2, 3, 4. Now watch carefully. How many parts of this shape has been shaded red? 1 part of this shape has been shaded, right? How many parts did we have in total? We had 4 parts. So this is the fraction. Again, we have 1/4. Now, a fraction has 2 parts. The one on the top, and it is called numerator, and there's one on the bottom, it is called a denominator. Can you say it again? A numerator and a denominator. There are so many things that fractions tell us. What does a fraction tell us? Let's see some examples. For instance, look at this image. There is a shape which has been divided into 4 parts and 1 part has been colored brown, right? So in this case, the fraction 1/4 tells us that 1/4 of this square is brown. Now check out this picture. Can you see some students? How many girls are there? There is just 1 girl. How many boys are there? There are 3 boys. Now, in this picture, we take the fraction 1/4, which says that 1/4 of this group of students is girls. Likewise, fractions can tell us a lot of things. Now, fractions are very important in our daily lives. It is not just something that is given in the textbook, which you must memorize. You use fraction every day. If you want to share something with your friends, you use fraction, isn't it? When you tell the time, you use fraction. For example, I will come after half an hour, right? You talk of time in terms of fraction. And you also must have heard when your parents go for shopping, they use fractions to buy the products. A half a kilo of potato, or maybe a half a kilo of chili, something like that, right? We use fractions every day. And you can also see fractions in your test results, isn't it? You get 9/10, you get 5/10, you get 10/10. These are all fractions and we need to know them properly. Now there are types of fractions which you must know. Look at this picture firstly. How many parts have this shape been divided into? 5 parts, right? Look again. 1, 2, 3. How many parts of the shape has been colored pink? 3/5 of this shape has been colored pink, right? Again, we have the numerator as 3 and the denominator as 5. Now, if you notice, the numerator is smaller than the denominator, right? This type of fractions, which have smaller numerator than the denominator, is called a proper fraction. Can you say it again? A proper fraction. Now, let us look at the second type. Here is an image. What part of this image has been shaded? 1/3, right? If we shade one more, that will be 2/3. One more, that will be 3/3. And now if you see, 3/3 have made a whole shape. So we also have 2/3 again. Now let us count the total thirds that have been shaded in this picture. 1, 2, 3, 4, 5. So we have a total of 5/3 which has been shaded. Now if you look at this, you will see that the numerator is greater than the denominator. It is different from the fraction that we have written above. This type of fraction whose numerator is greater than the denominator is called an improper fraction. The reason it is called improper fraction is, like I said earlier, fractions are a part of a whole. They are not a whole. So fractions are supposed to be smaller than a whole. But here, if you notice, you already have a whole and additionally you have 2/3. That means it is greater than a whole, right? So it is not a proper fraction, and something that is not proper is called improper. So this type of fraction we call improper fractions. Now let us look at the third type of fractions. Can you see this image? It shows 3/3, right? And it is a whole. So we write 1 whole. Look at the second image. It shows 2/3 of a shape, right? So we write it as the fraction 2/3. Now if you notice, we have written one whole number and a fraction. Why did we do that? And what does it mean? If you put a whole number and a fraction together, it is called as a mixed number. You put the whole number and the fraction together. You mix them up, so it is called a mixed number. Now, a mixed number is another way of representing an improper fraction. That's why improper fraction and mixed number are interchangeable. That is why we are going to learn the next part of this lesson now. Changing improper fractions to a mixed number. For that, let us take an example of an improper fraction, 11/4. Now there are different ways to convert an improper fraction to a mixed number. So let us look at some of the ways. And here is the first way, which would be by using models. We take 11/4 and let us make models for 11/4. Look at this shape. It has 4 parts, right? If we color one part, it will be 1/4. 2/4, 3/4, 4/4, right? 4/4 plus 4/4 give us 8/4. And then we have 9/4, 10/4, and 11/4. So we got the improper fraction. We represented the improper fraction using a model. Now see, 4/4 make a whole, isn't it? We have another whole there, another 4/4. And we have a fraction there, 3/4. Now if you combine them all together, we have 2 wholes, 1 plus 1, 2, and a 3/4. That gives us the mixed number, 2 3/4. So you have successfully converted 11/4, which is an improper fraction, to a mixed number, that is 2 3/4. Now let us look at the second way to solve this problem. This one is by adding to make a whole and a part. We add and then bring out a whole and a part. We take the same example. Now 11/4, how do we represent it in parts? Like we said earlier, 4/4 make one whole, right? 4/4 plus 4/4, that becomes 8/4, and we are left with 3/4. Now you add them as 4/4 give us one whole, the second 4/4 gives us the second whole, and we have a fraction left, that is the 3/4. 1 plus 1 gives us 2. We add that to the fraction. So our final answer is we have 2 wholes and a fraction 3/4, 2 3/4. Let us try the third way to solve this problem. That would be division method now. And you all know how to divide very well, right? So in this case, in a fraction, the numerator is divided by the denominator. So we have the numerator 11 divided by 4. So 11 divided by 4. 4 times 2 would be 8. 11 minus 8 would be 3. Now what we do is, we take the quotient, the answer to the division, right, as the whole number. We then take the remainder as the numerator, and we take the divisor and put it as the denominator. That way, you have a mixed number there again. Are all the answers same? Yes, right? So whichever method you choose to convert an improper fraction to a mixed number would give you the same answer. Now, as I said earlier, improper fraction and mixed numbers are interchangeable. So now let's convert a mixed number to an improper fraction. And this time we take the example 5 2/3. Again, there are different ways to convert a mixed number to an improper fraction. So let us look at the first way, again using models. Now we have to represent 5 2/3 using models. We have 3/3 here, and as you know, 3/3 make one whole. And how many wholes do we have in this question? We have 5 wholes, right? So 3/3 makes one whole, 2 wholes, 3 wholes, 4 wholes, and 5 wholes. What do we have left now? We are left with this fraction, 2/3. So we represent this using models again. 2/3. Now let us count the thirds. We have 3/3 here, right? So 1/3, 1/3, 1/3, 3/3. Let us count the thirds together. Can you count with me, please? 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3, 13/3, 14/3, 15/3, 16/3, and 17/3. So we have a total of 17/3, and that is our improper fraction. That is our answer. Isn't it simple? It is, right? Now let us look at the second way to solve this problem, and that is by adding the whole and the parts together. Earlier, we added to make a whole and a part, but this time we are adding the whole and the parts together. Please do not get confused with that. We take the same example. Now, as we discussed earlier, one whole means 3/3, right? So to represent the 5 wholes, how many 3/3 do I have to write and add? 5 3/3, right? Let's do that. 1, 2, 3, 4, 5. Then we have the 2/3 left there, which we also add on to it. Again, let's add all the thirds together. 3/3 plus 3/3, 6/3, plus 3/3, 9/3, plus 3/3, 12/3, plus 3/3, 15/3, plus 2/3 gives us 17/3, and that is our improper fraction, 17/3. Now the third way to solve this problem is by multiplying the whole number with the denominator and adding with the numerator. Sounds confusing, right? But check it out, it's the easiest one actually. We take the 5 2/3, and step 1 to solve this problem is you take denominator and the whole number and you multiply it. So in this case, 5 times 3 equals to 15. We got the product of 15, right? Now, remember that. Go to step 2. You take the numerator and add it to the product of 5 times 3, the denominator and the whole number. So in the step 2, we have 15 plus 2. 15 was the product of 5 times 3, and we added the numerator on it. That was the 2. So in total, we get 17. All you have to do is write that final answer as the numerator and then keep the denominator as it was in the fraction. Let me show it to you in a very short way now. Once you understand this, you can do it very quickly. We have 5 2/3, right? So what we do is we take the denominator and the whole number, so 3 times 5, then add it to the numerator, plus 2. And we keep the denominator as it is here, 3. 3 times 5 gives us 15. Add this 2. Keep the denominator as it is. Your final answer is 15 plus 2 is 17 divided by 3. This is the mixed number which you have converted to an improper fraction in a jiffy of a second, right? It's very easy, isn't it? Now that you have learned how to change a mixed number to an improper fraction and an improper fraction to a mixed number, let us look at something called equivalent fractions. Look at this shape, a square, right? This is a whole shape. Now, how many parts have this shape been split into? And how many parts have been shaded? One part has been shaded from the 2 total parts, right? So we get the fraction half. Now let us find equivalent fractions for half and check out how we do that. We take this half as it is and we split it further. Now how many parts have we split the shape into? 4 parts, right? And how many parts are colored? 2 parts, right? So we write that down now. And I have color coded so that you can better understand. So 2 parts of this shape has been shaded out of the total 4 parts, right? So we get the fraction 2/4. Are they the same? Yes, they are, right? Now let us take the half again. This time we split it into more parts. How many parts have we split the whole shape into? 6 parts. And how many are colored? 3 parts are colored, right? So how do we write the fraction? We write it as 3/6. Now look at this 4th image. Again we take the half and we split it further into more parts. Look at this. How many total parts do we have? Count. 8, right? How many parts are shaded? 4 parts are shaded, right? What is the fraction? We have 4/8. Now if you look at the pictures, you will notice that all of them are actually equal, isn't it? In the same way, the fractions are also equal. The value of the fraction has not changed, just the numbers have changed. So these are equivalent fractions. This is one way to find equivalent fractions, and there is also another easier way to find equivalent fractions. So eyes on the board, please. We take our example there, half, right? To find the equivalent fractions, we must not change the value of a fraction. So in order to do that, we multiply the numerator and the denominator by the same number. Let's do that. In this case, let's multiply it by 2. 1 times 2, same here, times 2. 2 times 1 is 2. 2 times 2 is 4. So the equivalent fraction for half is 2/4. Let's try one more time. This time with a different number. Let's multiply it with 3. 1 times 3, 2 times 3. We multiply both the numerator and the denominator by the same number. 1 times 3 is 3. 2 times 3 is 6. We get 3/6. Now, half, 2/4, and 3/6. They are all equivalent fractions. Their value does not change. Have you understood the lesson on equivalent fractions? If you have, let's move on. Okay, now let us try finding one more equivalent fraction. Here's the question. Find the equivalent fraction for 3/5. So for that, we take 3/5. Now what do? We take the numerator and the denominator and multiply it with the same number. 3 times 2 is 6. 5 times 2 is 10. So we get 6/10, right? One more equivalent fraction for that. We take the numerator and the denominator, and this time let's multiply it by 3. So we get 3 times 3, 9, and 5 times 3, 15. 9/15. So 3/5, 6/10, and 9/15, they are all equal. They are equivalent fractions. I hope you clearly understood the lesson on equivalent fractions. Now let us move on to adding fractions with same denominator. This is the easier part. Let us take an example, 5/10 plus 2/10. First, we represent 5/10 using a model, all right? For that, let us take a whole shape that has been split into 10 parts. We take 10/10. Now from there, we shade 5. So we make it 5/10. Let us do the same with 2/10. We take the whole and we shade 2 parts of the total 10 parts. Now that you have these two fractions represented, what we do is we put them together in one whole. So we have the 5/10 here and we have the 2/10 there. The reason we put them in one whole is because the denominators are equal, same in both the fractions. Both the fractions are a part of 10/10, so we can put them together. And now let's count these parts all together. 1, 2, 3, 4, 5, 6, 7. So we have a total of 7/10. And the sum of these two fractions is 7/10. Did you understand this part? Let's move on to subtracting fractions with same denominator, and again we use these two fractions. 5/10 minus 2/10. Let us represent 5/10 using a model, 5/10, right? Let us represent 2/10 using a similar model. Okay. Now what we do is, to subtract, we take the 5/10 and we take away the 2/10 from there. How many tenths do we have left? We have 3/10 left, and that is the difference of the two fractions. Did you understand? Okay, now this is the case of fractions with same denominator. What about fractions that have different denominators? For shapes that have different denominators, we would not be able to use the same whole, right? So we have another way of solving the problem. For instance, let's take this example. We have 7/10 first let's add 7/10 plus 2/6. Look at the two denominators. They are different, right? They are not equal. So what we do here is, firstly, we find the common multiple of the two denominators. Let us try it out. Let's say, to make it easier, let's say the multiples of the first number and check if it is common with the multiples of the second number, okay? The first multiple of 10 is 10 itself, right? So can we divide 10 by 6? Is 10 a multiple of 6? No, right? Now let's move on to the second multiple of 10, 20. Is 20 a multiple of 6? Can we divide 20 by 6? No, right? Let's move on to the third multiple of 10, 30. Is 30 a multiple of 6? Yes, right? Can we divide 30 by 6? Yes, right? 6 times how much is 30? Do you know? Yes, 6 times 5 is 30. So now we have found our common multiple and we use it to add these fractions. So here we write 30. But here it is 10. How can we get 30? 10 times how much is 30? 10 times 3 is 30. Now if you are multiplying the denominator by a number, in order to keep the value same, you have to multiply the numerator with the same number. We have to make it an equivalent fraction. Please remember that. So we multiply 7 by 3 again, and 7 times 3 gives us 21 plus, we said this is the common multiple, right? So we write 30 instead of 6 again. How did we get 30? 6 times what is 30? 6 times 5 is 30. So we multiply 6 with 5 here. And if we are multiplying denominator with the same number, with 5, we multiply the numerator with the same number as well. 6 times 5 gives us 30. 2 times 5 gives us 10. Now that the numerators are same, all we have to do is keep it as one numerator because they're same, and we just have to add the two numerators. It's very easy, isn't it? Now that we have the same denominator as 30, we keep it as one denominator and we only have to add the numerators. So 21 plus 10 would be 31, right? So that is the answer. That is the sum of these two fractions. Now if you notice, this is an improper fraction, right? So what you can do is you can convert this into a mixed number. Can you try it yourself, please? Because we have already learned how to change an improper fraction to a mixed number, right? Now let's try with subtraction. We will use these two fractions again. 7/10 minus 2/6. What do? The procedure is similar to addition. We first find the common multiple, and in this case, you already know what the common multiple is, right? So we have the common multiple 30 here. 10 times 3 is 30. 7 times 3 is 21. We'll write it here. Minus, we write the common multiple here for the denominator as well. 6 times 5 is 30. We multiply 2 with 5. 2 times 5 is 10. Again, all you have to do is write one common denominator because the two denominators are same. We just write it once and we take 21 minus 10. 21 minus 10. Can you find the difference? Okay. We get the difference 11 and the denominator is 30. So our difference for these two fractions is 11/30. Now this is a proper fraction because the numerator is smaller than the denominator, right? So you don't have to change it to mixed number. Did you understand this lesson clearly? Okay, if you have, then there are some questions that I would request you to try it at home in order to understand if you have understood today's lesson on fraction computation. Try to change 4 3/5 to an improper fraction. 4 3/5 is a mixed number, right? Try to change 14/9 as a mixed number. Did you note it down? You can also give a try to find 2 equivalent fractions for 2/3. Try to add 2/9 to 5/9. Now here they have the same denominator, so it's easy to add, right? Try to subtract 7/10 minus 2/10. Again, the denominators are same, so it's very easy to subtract. Please try these questions out, and I'm pretty sure you would be able to do it all correctly, because out there you all are wonderful kids. All the best. Thank you for attending the lesson, and I'll see you in the next lesson.